Hello, I'm Unik. This will be another episode of me solving genuinely approachable pencil puzzles. But first, I wanted to highlight that there is an event called Puzzle Grand Prix. There is also Sudoku Grand Prix. They happen every 4 weeks, so more or less every month. The Sudoku stages and puzzle stages intertwined with Sudoku stages 2 weeks before, and the third round of Puzzle Grand Prix is happening right now, and it will be open for almost 2.5 more days. So if you want to try competitive puzzles or just try to solve harder puzzles, you can try to participate in this one. There is instruction booklet which you can check out beforehand. You can see that there are a lot of different genres. There are rules and examples for all the genres that will be present in the competition, and then if you so desire you can start the competition that will give you the PDF with puzzles. I mean, you can download the PDF first, but it is password protected, so when you start the competition you get the password and you have 90 minutes to solve as many as you can. The puzzles are pretty hard. Obviously, top contestants can solve everything in 90 minutes, but I'm very far from being a top contestant. So the goal I'm striving for is getting 4 points for a minute, so something close to 360 points. Sometimes I succeed, sometimes I don't. And also, unlike Puzzle Ramayan, which I was talking about the last time, you do not have online checking here, and you also do not have online interface, so you just get a PDF, and you're supposed to print it out and solve on paper. I started doing that again this year, but last year I solved on an iPad, which I think is a kind of cheating, because I have undo basically, and also bigger variety of writing instruments. But I'm not top contender, so I thought it was kind of fine. But yeah, this year I'm actually printing it out and solving on paper. So yeah, if you want, you can try your hands in this competition. 2.5 more days. This is a competition I consider to be the most important, but it's probably different for different people, and probably other than World Puzzle Championship, it's all just online competitions. Puzzle Grand Prix, if you want. And let's go back to Mind the Gap number 4, just collection of February 2022 genuinely approachable pencil puzzles. It's very hard to say it. And the one we stopped at was February 24th, which is a genre called Nemo, puzzle by Shye. I don't remember this genre, but It looks somewhat familiar, so probably I have solved like a couple, but I don't remember what it's about. So let's check out the rules. Place a number from the range given outside the grid. So it will be like 1 to 4 for the main puzzle, but 1 to 3 for the example. Into some cells so that each row and column contains every number from the range with no repeats, and shade all of the remaining cells. So like in the example we have like 5 by 5 grid. In every row and every column there should be like 1, 2, 3 and 2 shaded cells, I guess. Cells with arrows must contain a number that represents the distance to the first shaded cell appearing in the indicated direction. So like the 2 here means that the cell on distance 2 in that direction must be shaded, but all the cells before that must be unshaded. So it is the first shaded cell. So like this kind of combination of putting numbers and shaded cells, and numbers mean something about shaded cells. Let's look at the example. So we will need to cycle between putting numbers and shading cells, which is like not the best, but have to do. So the numbers that are given and arrows must be unshaded and must contain numbers. In this top row we already have 1, so it cannot be 1 here, so it must be 2 or 3, but also we have 3 in this column, so this must be 2. But also just from the top row we could have actually understood that it cannot be 3, because 3 here would mean that the first shaded cell would be here, then those 2 must be unshaded, but we don't have enough numbers to do that. So this must be 2, which means like this. Why is it so small? Because it's center, not normal. And in this row we have like 1 more unshaded cell, which must be a 3. And so the last remaining cell must be last remaining cell must be shaded. What's next? This cell must be like pointed at some shaded cell, so this one must be shaded, and this cell must contain a 1. In this row we have 3 more free cells, and there must be a 3 in this row, but it cannot be in the first or second column because those columns already have 3. So it must be 3 here, and again it cannot be 2 here, so it's 2 here. And the last one is shaded. So now in this column only 1 is left, and it will be in this cell with an arrow, which means that the one to the right of it must be shaded. Now in this column we already have 2 shaded, so this one is unshaded, and we can probably finish with all the shadeds. And not yet, still 2 options. But we can probably place some numbers now. It cannot be 1 here, because this one is already unshaded, so it must be 2. Why I cannot go further down? This is kind of stupid. Okay, so this 2 means that this one is shaded, and now we are done with shadeds. And now I need to just place all the remaining numbers, just following like normal Sudoku, like Latin square rules. And I again need to remember to increase the puzzle, because on Penpa it's kind of small, but this is too big because I need to switch between modes. Okay, let's check out the main puzzle. How did that happen? Well, okay. Somehow I solved it before, which is weird. Oh, probably I did look at Shye's own blog, and they posted some of the puzzles there, so that might be how I have seen this puzzle. Well, we will solve it again. Not that I remember anything. Okay, all the clues must be unshaded. Don't know where to start now. The fact that I already solved it threw me off. Well, you can see that in none of those cells we can have a 3, because the corresponding cell in that direction, like on distance 3, is already unshaded. But for all of those cells, for example, for these two, we already have a 1 in that row, so it can't be 1, but it also cannot be 3, because we cannot have a shaded cell on distance 3. So it must be 2 and 4 in some order. It also cannot be 4 here, because 4 would be outside of the grid, so this must be 2 and this must be 4. 2 means that this one is unshaded and this one is shaded, and 4 means that all of those are unshaded and this one is shaded. This one also must be shaded because it's the last cell in this column, and we need 2 shadeds in every column. And in this row, this one also must be shaded. This cell cannot contain a 3, cannot contain 2 because it is in the same row, cannot contain 4, so it must be 1. And that means that this one is shaded. Now we have 2 shadeds in the first row, so those are unshaded. This is not a 1, not a 4, and also not a 3, so it must be 2. Which means that this one is unshaded and this one is shaded. And this must be 3. And in this column, 1 and 2. Okay, great. What's next? 3 in this row, the last number left. And now we can also finish the first row, because this 3 disambiguated 3 and 4 here. This cell is not a 1, not a 3. It cannot be a 4. Even though the cell on distance 4 is shaded, there must be another shaded somewhere closer. So it must be a 2 actually. And so the shaded is here, and those are unshaded. Now this cannot be 1 because the cell on distance 1 is unshaded. It cannot be 2, it cannot be 4, so it must be 3. This cell must be black because all the numbers are already used up in the row or a column. Now in the last row we already have 2 shaded, so those are unshaded, and we actually know which one's there because of this 2. This is 1, this is a 2. Now in the next to last row this is a 4 and this is a 1, and now this is a 4. Now in this row we have one left, and it cannot be in the first or fourth column, so it must be in the third one. And just finishing up, putting the shaded cells by counts in columns, and the last numbers are 3 and 4. Great. The next puzzle is Nagenawa by Jovial. Will be some crossing loops, which I don't like. Draw rectangular loops through the centers of some empty cells. The sides of different rectangles may intersect each other, but not turn at their intersection or otherwise overlap. A number in a region represents how many cells in the region are visited by the loops. Okay. Note about the software: right-click cells to place an X in them. You might find that helpful. So X is for like the cells that are not used by the loops. So we are drawing rectangular loops, and the regions, the numbers in regions say how many cells are used by the loops. Okay, let's try it. So this 4 means that all the cells are used. If we use up this corner, it would, like, the corresponding loop will have to go like this, but then we will also use up this other cell in this region, but we only must use one of the cells. So that cannot be true, so this one is unused actually, and this one is used. And since it is now in the corner, kind of, because we cannot go here, it means that it will go like this. Now this one is used, and in the top right region we have already used up one cell, so the others must be unused, and the loop must go down. Also, this cell is now a corner, but our loops must be rectangular, so when they form like internal angles like this, it actually means that it is an intersection of two loops, and here also. So yeah, the top loop must continue down, and this left one must continue to the right. Now in this region we have already used up one cell, so this one is not used, and this is a corner. We have also used those cells, but that's not helpful because in this region we don't have a number, so we don't know anything about it. In this two region we must use both, and this is an angle, so it's like this. Now if we continue this rectangle up, it will have to turn here, but then it will intersect with this loop, and so they must go further, but now all 4 cells in this region are used, which is bad. So it cannot go further up, it must close here. So this cell will be unused. Well, because otherwise like it will be an angle and it must go down, but also because in this region we have already used up 3 cells. Now this loop cannot go further down because it will have to go even further and further, but there is nowhere to go. So it must actually close here, and this one goes further. In this region we have used up 1 cell, so this one must be unused. Now this loop cannot go further to the left because it will reach this cell that must be unused, so it closes here. And this one cannot close here because we still need to use up 2 cells in the slower region, so it must go further. Okay, great. Let's look at the main puzzle. Zeros. Zeros are nice because it means that we're not using anything here. Also, we have a lot of force for 2x2 regions, and also this 6 and this 6 for 2x3 regions, which means that all of those cells are used. Okay, great. Those 1 regions near the corners are probably also helpful because, well, this one is actually in the corner. We cannot use the corner because otherwise we would use more than 1 cell. But then this became the corner, and again we would use 2 cells, and the same is true for this one, so we actually must use this cell, and we have 3 corners now, which is great. And all of those internal angles are actually intersections. And this again is an intersection. Okay, so those 3 will be 3 different loops. And this one cannot continue to the left because it will use up more than 1 cell in this region. Actually, this region is also kind of in the angle, so it also must be true that this cell is used, and basically we have like symmetric situation. Kind of looks like a menorah. Okay, this loop cannot go up because those are x's, so it just closes here, but all other loops will go up. Now in those 1 region we have already used up 1 cell, and means that the loop closes here. This one goes even further, and in this 2 region we have used 2 cells and have to close this loop here. Okay, that's a big chunk of the puzzle. Now this one is a corner, so we can draw it like this. There is also like this 7 region where we have to use all cells except 1. And it actually looks not easy to like not use exactly 1 cell. We have to use something in the lower row, so must have a cycle like this. If I close it here, then we will have another one like this and use up all the cells, so I cannot close it like here. But now I cannot continue it further because that would also use up all the 8 cells in this region, so I have to close it here. And now we can see that we're not using this cell, and this one becomes a corner. Now in this 1 region we have used up 1 cell, so other 3 must be unused, which determines this loop. Now those are corners, so this is the loop we want. Also we have like another those 2 1 regions that are kind of in the corner, so again the cells we are using must be here, and they are corners. And now in this 2 region we have already used 2 cells, so all others must be unused. Close those 2 loops. This 1 region in the corner, so we use this. Cannot use any of the left because I will use up both of them, and that will be already 3 cells in this 2 regions, so must use this one. but I also must somehow use this cell. I cannot use it horizontally, so it must close the loop here. And now I have more corners here. And well, we can see that I should just close this loop here. If I were to continue it to the right, that would already use up 4 cells in this 3 region, so have to close it here. That wasn't too bad, probably because it's genuinely approachable puzzle. And yeah, I usually struggle with crossing loops. The next puzzle is a supersized Hashiwokakero, just Hashi by Tyrgannus. This is one of more, I guess, well-known outside of pencil puzzle community puzzles. I think maybe it's just my bias, because I had an app on a smartphone with this puzzle and I played it a lot. So yeah, I have some experience with those puzzles. It has a kind of unique presentation in that there is no grid lines or even points like in Slytherin we would have. Just the circles, but we still will follow grid lines. So the rules: connect pairs of circles horizontally or vertically, so only by grid lines, so that all circles form one connected network. So everything must be connected. Connections may not cross one another, and any pair of circles may have at most 2 connections between them. So for any 2 pair of circles, it can be 0, 1, or 2. Numbers in circles represent the amount of connections they're a part of. An unnumbered circle can have any number of connections, but must be connected. And everything must be connected. All the circles must be connected in the end. Since this is mostly competitive programming channel, you can think about it as drawing a graph, and we are given degrees of those nodes. This graph must be connected in the end, and between every pair of vertices we can draw 0, 1, or 2 edges. Let's look at the example. So this genre is mostly about looking up for some nodes that don't have a lot of potential neighbors and connecting them, and then it will already drawn edges will block some other edges, which will decrease the number of potential neighbors for some other vertices, and so on. But there are also some patterns that you need to notice, that if you connect something in a particular way, it will use up all the degrees we have, and we will have a disconnected part. So we can start with this 4. Every circle can only have at most 4 neighbors, left, right, up, and down. But for this 4, we can see that up and left don't have actual neighbors, so it's only right or down, and we can have only 2 edges to each of the neighbors, but we must have 4 edges going from the circle, so we must have 2 to each of them. This 5 can have at most 3 neighbors, and well, if it was a 6, then we would just draw 2 edges to each. But since it is a 5, we have to draw 1 less somewhere, but it still means that for every direction there is at least one edge, and like there would be at least one edge here even if this wasn't a 4, but we already know that there are 2 edges here, so it's fine. And drawing just one edge is already very good because like it blocks the neighbors, the possible neighbors for other circles. Well, there weren't a lot of possible neighbors to begin with. I think we didn't actually block anything because they were already not on the same line, but now it is easier to see that this one has only one possible neighbor. And now from this empty circle we must continue to the right because everything must be connected. Also this 3 in the corner has 2 neighbors and must have at least one edge to both of them. Now if I draw a second edge here, this group will be cut off from all the rest because like this circle doesn't have any potential neighbors left, and from this two I already used up all the degrees, so it must like stay one here. I actually don't know how to mark that, but what I can do is just connect this to outside world because that's the only edge that can go from this connected component. And now to finish this 3, I need to draw a second edge here. And actually this node is finished, but I cannot mark it. Okay. Well, not that I can connect it with anything. This 2 has only one potential neighbor, so both will go here, must continue to the left. Again, like cannot draw a second edge because that will cut off this component. So must continue here, and from this node again must continue down. Now we can return to this 5. Since I cannot draw a second edge here, I must draw it here. And like for this lower component, still I need to connect it to the upper one, and the only way I can do this like this. So yeah, this puzzle was mostly not about like following numbers, but just about drawing a connected graph. So I don't think it's a good example actually, because like it doesn't show like that. When you draw a bridge, you close up some of the possible connections. I think like in this picture we have more or less all connections, like except this one, that were actually possible from the start in this graph. Okay, but I'm sure that in the main puzzle we'll have to see like more of blocking. Like for example, there is this 6 on the edge of the board, which means that it doesn't have a right neighbor, so it must have 2 edges to all 3 neighbors. And now we basically cut off the higher part from the lower part, and like they have to connect through like small number of channels that we have left here. We can still like hunt for big numbers. This 7 is a lot. 7, like it's almost 8, so it must have 1 for every direction, but also one of the neighbors is just 1, so we can only have 1 here, so it must be 2 for everything else. Now like for one of those patterns where you can create very small disconnected component. If we have those 2s that we can connect to each other, we cannot draw both edges here because they will not be like, we will not be able to leave this component now because we have used up the degrees for both of them. And since this 2 has already only one other neighbor, we must have an edge here. And now for this 2, like I blocked it with this edge so it cannot go down. There's nowhere to go up or right. So both edges must go left. And now this 2 actually, like the second edge also must go to this 4. What else? 3 in the corner just gives 2 edges. 5 on the edge gives again edges to all the neighbors. Another 5 on the edge, and also one of the neighbors was 2 that already like used up another its degree, so must have 2 edges to both of those neighbors. Now this 4 has 2 more degree and 2 neighbors with just 1 degree, so we must use all of them. This 3 cannot have like another edge to the right, so it must go down. Okay, this 5 is on the edge. Well, there wasn't anything to the right, but even if there was, we cut it off with the 6 from the start. The 4 in the corner just has 2 edges in both neighbors. This 4, like it was on the side, but one of the neighbors was used up, so for the 2 remaining neighbors, again, both edges are drawn. This 3 only has 2 neighbors left, so it's kind of in the corner now because we have like cut 2 other directions off. And this 4 is in the corner. Well, it was in the corner from the start. This 2 doesn't have any other neighbors. And now this 2 cannot have like its second edge up, so it must go to the left. Okay, from here I should be able to finish the upper part, right? We have this like long line that is uniquely resolved here, and this one must go right. Okay, I guess this finishes the upper part. Now this 3 only has 1 neighbor left. This 3 is in the corner, and this neighbor could only take 1 edge, so it will go to here. This 5, it has 3 neighbors. This one was cut off, so it goes here. I wanted to say like, I mean, I drew it accidentally, the like long edge, but it is correct because like after we used up 1 degree by this 2, this 4 like kind of became a 3 with just 2 neighbors, so it must have an edge to both of them. This 6 doesn't have one of the neighbors, so it has 2 edges to all 3 other neighbors. The 1 is kind of a dead end because like we cannot connect through it, right? It can only be a leaf in the graph. So for this group of nodes to escape, these 2 must be connected here, and also like this node must be connected to 2, and we have used up all the degrees of 2. Now this 1 must connect to the 4, and for the last connection must go here. If I connect this 2 down, I will cut off this component, so we do not do that and connect it to the 1 instead. And we have 1 more degree for this 3. It cannot go down because it will again cut off the component, so it will go right. From this 3 we have used up 1. we can go one more to the right, but then like we cannot go two to the right because the 3 only has 1 degree left. So it goes like this. But if I row 2 down, then again it will cut off the component. So we connect it like this. Okay, now that component is like connected to the big one, so we do not care that this 2 can only connect to the 1. This 5 is on the edge. This 3 has only 2 neighbors, and one of them is 1, so we should take 2 edges to the other neighbor. Now this 5 cannot get the second edge down, so it must have 2 edges left and right. Now this 1 cannot go up or right, so it must go left, and that's the end. Pretty simple puzzle, as most of them are in this series. Yeah, but it is a nice genre with like it is possible to create hard puzzles here. The next puzzle is Kurotto by Freddie Hand. This is one of the genres that is present in the Puzzle Grand Prix that is happening right now. It is another shading puzzle. Rules. Shade some cells so that clues represent the total size of the orthogonally connected areas of shaded cells that share an edge with the clue. Clued cells cannot be shaded. It's an interesting choice to phrase it as one sentence, but so we shade some cells, they will create some connected components. We cannot shade the circles. Like in those puzzles, all circles have numbers, but that is not strictly required. Like there can be circles that just means that this is an unshaded cell. So we have those components, and then for every circle, we look at the components that are orthogonally connected. So like contain one of the neighbors of that cell, and we count the sum of their sizes. So it's like 3 plus 2 plus 1 for the 6, which is a 6. And like, yeah, the numbers must give the size of the components. It is not shown in this example, but like if, for example, this cell was also shaded, we would have this component of size 6, which like bounds touches this clue on 2 sides, but it is still counted only 1, so it would be like 6 plus 1, 7, not 6 plus 6 plus 1. So let's look at the example. Zeros just means that we cannot have any shaded cells near them. Now those 3 and 2 have only one like exit from them, so it must be shaded, and those components must be of size 3 and 2 respectively, and there is only one way to grow them. So we already cleared like half of the field. Now this 4 already has a component of size 3, so 1 left and 1 exit, so it must be a 1. This 6 already has a 3. It can have 1 more here, but it needs like 3 more, so at least 2 must be from the upper side. So we get 2 here, but now we can see, and it was like helpfully shown to us by the redactor that this 4 is already satisfied, so we cannot increase this group more, and this cell must also be unshaded because otherwise we will have like more than 4 for this clue, and for the 6 we actually do need this 1 cell to get to the 6. So now let's look at the main puzzle. Don't have any free zeros, but we have like those 5s in the corner that only have one exit. So we must exit here. And we cannot go lower from this clue because it would touch the 4, but we know that this component must be a 5. It cannot also touch the 2, and it cannot touch the 1. So it goes further here, and it still needs like one more cell. Now this 4 also has one exit, and they cannot connect because, well, first of all, it will be component of size 6, which is bad, but also like we know that this component is of size 5 and this is of size 4, so they're definitely different components. It cannot be the same component. Okay, I think that's more or less everything we can get from this top left corner, except like now we know that this component have to go here or here, and in both cases this cell must be unshaded, but it probably doesn't give a lot. We do not have the same situation in this lower right corner, even though like we again have a 5 in the corner and it must exit here, but it can go up because this is just a 6 and like +1 here would be fine. So we should probably look at some other place. For example, this 2 now only can exit to the right and it cannot go down from here because it touches the 1, so that component of size 2 must be here. And now we get more information about those 1 and 3. Both have only one exit left, so they take it. This component must be of size exactly 3, so it doesn't fit just in the upper side, so it must go at least 1 down. Now it touches the 5, so this will be a component of size 3 somehow, like by either taking this cell or this cell. So for this 5, it is 3 plus, I guess, 2 on the left. So like there is on the only other exit, so it must be a 2 here. And now we can see that this component cannot go down because it would create a 5 already for this 4 clue, so it must go up. And now this 4 clue, it has 2 and must get 2 more, only has one exit here, and just like I have shown here, like we should take either this cell or this cell, so this one is unshaded. And finally this 5 we can finish because we eliminated 2 of the 3 options, so the last one must be the correct one. Now this 4 can go 1 more down, and this will be a component of size 4 that will touch the 5 on either of those sides. And we can see that like in both cases, like kind of those 2 exits are like touched by that component, even if we do not actually take it. Like if we take it like this, we still cannot use this exit for this 5 because it will like go to the same component and it will be it will make it bigger than it needed to be. So this 5 is a 4 here in one of 2 ways, plus 1 on the right because that's the only other exit left. So it must be exactly 1, so those cells are unshaded. And now this 4 has only one exit, and we can, even though like this component of size 4 and this is component of size 4, they could be the same theoretically, but they just too far from each other. It would be 5 already, so it must be unshaded. And this 4 actually goes right, and this 4 goes here. Now this 6 has 4, needs 2 more. Now this 5 has only one exit, which is here. And it cannot go up here because this 6 already has 2 from the left exit, and plus this 5 it would be already 7, which is bad. And now those two 5s actually connect. Now this 6 has 2 and 1 more exit, which must be a 4, which cannot touch this 1. It must go further to the right. And it looks like if I take this cell, it will block this component. Like, I will not be able to take this cell, and here I cannot grow to 5. So this cell must be unshaded. So we can see that, like, we know that those two components must be different, and if I increase this one to the right, they like cannot coexist in the same space. So this 4 must go up, again can touch the 1, so it goes here, the 1 has only 1 option left. Now we can see that this 5 actually must take this cell, because otherwise it doesn't have enough space. So this 6 now is a 5 plus 1, I guess. So this cell must be unshaded, and the 5 ends here. And we end up this 4 with the last shaded cell. Very nice puzzle. Yeah, like there is a difference between puzzles being easy and puzzles being just apply the rules until like the puzzle is solved. This puzzle is easy, but like you need to see that like one step ahead instead of just applying the rules until everything is done. Okay, and the last non-bonus puzzle for that February of 2022 is Circles and Squares by Eric Fox. New innovation by Anonymous25 on a style of shading puzzles such as Narikabe or Tapa. Don't think I have seen this one before. The rules. Shade some cells so that all shaded cells form one orthogonally connected area, and each orthogonally connected area of unshaded cells is in the shape of a square. Cells with black circles must be shaded, and cells with white circles must not be shaded. No 2x2 region may be entirely shaded. So it kind of reminds me of Statue Park, except like the colors are flipped and we are not given a set of figures to place, but we just know that all the figures must be squares. And there is also 2x2 rule, which is not present in Statue Park. Okay, maybe it's not that close to Statue Park. So, okay, we are shading some cells. Circles just say what is shaded and what is unshaded from the start. The unshaded areas must be squares, shaded must be connected, and no 2x2 region may be entirely shaded. Okay, let's see the example. Just using up the givens. This shaded must escape because like shadeds are connected. Also, if this one is unshaded, then this one will also be unshaded, and this is certainly not a square and never will be, so this one is shaded. So for those two connected cells to be in a square, it must be at least 2x2, so it grows like this, and now it's at least 3x3, and now it's done. Cannot be a 4x4. So we surrounded by shaded cells, and also this one is shaded because those shadeds needs to escape somewhere. Also this one must be shaded because if it's unshaded, then like we have this separation with unshaded cells. This one is shaded. Now this is 2 by 2. So the last one must be unshaded, and it must be a square so it cannot propagate further. So this one is shaded. This one is unshaded because of this 2 by 2. And those two are not connected, so to be a square it must be a 2 by 2 square. This must be 1 by 1, so it must be surrounded by shaded. This one is also shaded to connect this corner. Now this 2 by 2. This must be unshaded. It's a 1 by 1 square, so this one must be shaded, and the last one must be unshaded because of this 2 by 2. Okay, so the example kind of flew by. So let's see the main puzzle. 4 is a lot. It must be a 4 by 4 square, but cannot be bigger. And like all of those must be shaded. This is a 2 by 2. Again, cannot be bigger. And we have some 2 by 2 potentially shaded, so need to put the first unshaded. This can only be 1 by 1 square. This is shaded, and this is shaded because this needs to escape. Now can do the same for the lower part of the puzzle. So get our 3 by 3 and 2 by 2 squares, surround them with shadeds, have two potential 2 by 2 of shadeds. So those must be unshaded, and now they're connected, so it must be 2 by 2 and cannot be bigger than that. Okay, this one is also shaded because those need to escape. And this is a 1 by 1. And this is now potential 2 by 2 shaded, so this one is unshaded. It cannot grow more, so those are shaded. This is a 2 by 2 potentially. If I grow it further to 2 by 2, it will connect to this cell, and now it's not a square, so those are shaded actually. Now this one I also cannot grow because it will connect to this one, and again not a square. This creates this potential 2 by 2. Now must grow the square to 2 by 2. It cannot be bigger than that, so surrounded by shadeds. It's 2 by 2 of shadeds. This must be unshaded, and it is 1 by 1 square, so this is shaded. Those two unshaded because of 2 by 2 shadeds, and this one is shaded. Yay! Alright, so we are done with like the calendar February, but there are some bonus puzzles here. 5 items of them, and so we will solve them in the next episode. And that's it for this episode. Go solve some puzzles. Go solve Puzzle Grand Prix if you want. And I'll see you next time. Thanks for watching.